Well, thank you everybody for being here. This has been an interesting 2 days. Just this morning we heard from Chevron about projects that they are doing. We heard on transportation, storage, steel requirements from Valorec, and then end use. It was brought up a little bit, right? The speaker from Exxon made some good points on what is pragmatic and going to happen this decade versus not. So the goal for this panel is to deep dive into a few aspects that we haven't talked in detail. The first one is production, right? How do we produce the low carbon hydrogen molecule? What technology it takes? What feedstocks it takes? What are the resources required? The second thing we want to emphasize is value chain integration for large scale hydrogen production. Once we are past the early stage projects as an industry, as an ecosystem, how do we scale it? And then lastly, we'll talk about the end users across sector. We have a very diverse panel here. I would like to introduce. We have Yohei Hayakawa, who is the Senior VP of Energy Transition at Mitsubishi Heavy Industries. I'm looking forward to your developer perspective. We have Nigel Jenvey, Vice President Energy Transition Project Development from Baker Hughes. Looking forward to your end-use technology perspective. And then we also have Takashi Morishita from Asahi Kasei. He is the Corporate Venture Capital General Manager. Looking forward to your investor perspective. I'd like to start by introducing a little bit about myself and the company I represent, and then would request all our panelists to do the same. I represent Technip Energies. It's a company focused on engineering, technology, and project delivery. We have been delivering some of the most complex, first-of-a-kind, large-scale projects as far as it goes with chemical transformations for over 65 years. Our hydrogen legacy expands for at least 50 years, where we have executed on more than 280 projects on the natural gas feedstock-based steam methane reforming side, and we have around 80 references on the green hydrogen side. This has been done globally. I'm here to bring some of that perspective, what it takes for what we consider a traditional market, but it has a new flavor to it. We are all looking to decarbonize. There's technology that's going into it. There's new business models going into it. So seeing how this 100-year-old molecule is adapted to the needs of today and beyond. I would request everybody to introduce themselves and their companies.
So my name is Yohei Hayakawa. I'll introduce the Senior VP of the Energy Transition Division of Mitsubishi Heavy Industries Americas. Mitsubishi Heavy Industries Mitsubishi Heavy Industries MHI groups have two pillars for the energy transition. One is about the CO2, another one is the hydrogen. For the CO2, we have the CO2 capturing technologies. For the hydrogen, we have some technologies for the demand side. One is about for the hydrogen-fired gas turbine, also hydrogen gas engines. We're also developing hydrogen production systems like SOEC or AEM. On top of that, we are also doing some kind of startup investment. We're learning from Takashi, but we'll still be doing some investments for like hydrogen and both CO2 areas. So I'm very excited to join this panel, and thank you very much for having me here.
My name is Takashi Morishita. I work for Asahi Kasei Corporation, and Asahi Kasei is a multinational chemical firm. And I'm reading Asahi Kasei corporate VCR, and we are looking for a business opportunity through the investment to startup. And so far, we invested over 60 in the startup globally. Then we acquired 2 of them. Then investment in the sustainable sector, including hydrogen, it's a little bit different from other sector because it takes a time to go to market and the monetization is challenging. Then we set up a separate investment framework, mainly focused on sustainable, starting from April 2023. And the purpose of this investment framework is not only create a new business, but also to participate emerging ecosystem like hydrogen. And currently, we are focusing on hydrogen and lithium-ion battery for this investment framework. And we invested the two companies in the hydrogen sector related to AEM technology. And we are very excited. I'm very excited to have participate in this panel discussion.
Thanks, Parul. So great to be here. Nigel Jenvey from Baker Hughes. Baker Hughes is an energy technology company. I'm sure many of you in Texas will know of Baker Hughes, its legacy and its past, mainly in the subsurface. But the company was fundamentally changed in 2017 with GE Oil and Gas investing into Baker Hughes and then merging the two companies together underneath the Baker Hughes umbrella and brand. And what does that mean? That means we're pretty differentiated when it comes to energy technologies. We both have subsurface and surface technologies. In the surface space, some of you may be surprised to learn we're number one in LNG equipment provision across the world. We're also number one in nuclear power plants for sensing and valves across the world. We also do sensing for wind turbines and condition monitoring. So we have a lot of capabilities spread across the energy supply chain in lots of different areas. Our history in hydrogen goes back over 100 years. Ammonia compression, hydrogen compression, and I'll be talking a little bit about some of what work we're doing with our partners and customers across the world when we get into some of the slides. So great to be here, give you a bit of intro. Thank you, Paul.
Sounds good. Well, let's start with you, Yohei. You mentioned about Mitsubishi and their very pioneering project, especially here in the United States. It's commendable how well thought the project has been and how you've put together, innovative ways to have a demand, create supply, utilize the infrastructure, utilize the right technologies. I'd like your perspective as a developer on what it takes to make these early stage projects kick off.
Yeah. And for my introduction, I will be introduced back from the technology providers, but being a developer, that was a new challenge for us, a big challenge for us. First, let me introduce about the projects, which is we call it an ACES Delta project. In the very early morning sessions, Osina has already explained, touch on that project, but it consists with two projects. One is about the Intermountain Power project. That project is the replacing the coal power plants to the gas power plant. Communicating with the IPA, the Intermountain Power Agency, we resulted that they are very interesting about for further decarbonization. So that means we did have the hydrogen high blended gas turbine technologies with the natural gas. So they just didn't select it as a natural gas turbine, but hydrogen fired gas turbine for this project. So resulting this decision, we also set up another project, which is called the ACES Delta project. This is basically consists with two things. One is the hydrogen production, and the second one is the hydrogen storage. We also had a good lecture from the hydrogen storage in a few hours ago, but it will have a salt cavern together with creating with the green hydrogen. What is unique for this? Is they're utilizing the excess of the renewables to making the hydrogen and they store it at the salt cavern. So, and it is not like a short-term duration, it's suitable for long duration. So, for example, we store it in spring and summer seasons, and then we use that hydrogen with the gas turbines to generate the power with lower carbon intensity. So that was the project, and there was very, very early engagement happened in 2022. So why did that happen this? Because this project was FID before the IRA has been declared on that. So one thing is, well, there are many factors to come to the FID: financing, economics. We had to find off-takers, we need technologies, we might have some incentives and the regulators. But what I would like to focus first is about the infrastructures. This project was have a good condition for the infrastructures. Looking about the map here, you'll see along the DC transmission line here. It was an existing transmission we could utilizing for having the electricity renewables to the site in Utah. And after they have been generated the power in the Utah, they could directly transfer it to California. And as you know, that California has a very strong commitment for the decarbonization. So we could utilize that existing facility. Also, we could have a good geographical storage opportunity for salt cavern, which is very close to the conventional power plant. So these are one of the fortunates we had. Another things we had was the DOE loan program for $500 million. We could have good incentive in this project. So there's many things, but to come up with these projects. So I'm thinking that it's not easy because we are creating a market for hydrogen, but there should have some good conditions in the United States. There's a lot of resources for geologically and the sun and wind in the United States. So that we have to figure out where and how we can figure out these kinds of opportunities. The last thing I'd like to touch on that is another thing is about the technologies. If you go to the next slide, Mitsubishi Power, which is the MHR company, provides the hydrogen system, so hydrogen production system, which is the electrolyzer plant. Originally, this electrolyzer is not our MHI technologies. It's a Norwegian company's technology, Hydrogen Pro, but we have decided to validate their technologies for thousands of hours in our facility in Japan, in the factory in Japan. So technologies is very important. Of course, it's to satisfy that it's very important to make it easy. So that's what we think is very important for engagement of course.
Thank you so much for sharing that. It's interesting to talk about knowledge and validating it. I'd love to hear your technology investment and technology development and how that plays a part in these projects to start on.
I think the investment in the hydrogen sector, other sectors in terms of station and storage and navigation especially in the later stages of construction companies. Because also ways that money from startup investment. But I think similarly for one of the next generation of hydrogen production. Sector. see especially very reluctant investment in the sustainable sector because of this sector. Then I think importantly, there are expectations of the corporate not only providing but also in the market portfolio company such as manufacturing capability and resource manipulation of the portfolio. And since in this sector, the investment and also collaboration definitely is very important in this sector.
Your take, on early stage as well as scaling. What makes this possible?
So technologies and my managed strategy for the great users and implementation technology investments to have a venture capital company corporate for VC and invested through equity interests and also socializations strategically different places over the last few years with 2.1 billion into those technologies in the future. So it's just like examples of third generation processes because cost out performance improvement green electrolysis are source the future scale for hydrogen transmission system applications. Of course, also because of our gas turbines used various institutions around the world, but also focused on process combustion, but also combustion and hydrogen combustion, as well as ammonia combustion. Some of the technologies that looked at to produce hydrogen are particularly basically it's turbines, it's coal, but it's basically pyrolysis, not conventional pyrolysis due to a relatively slow reaction, but fast pyrolysis that can keep up basically by gas turbines and scale. We wanted to improve combustion and decarbonisation. Of course, that's in sustainable carbon. That's sustainable carbon we looked at using ammonia. What is now is sustainable carbon investments is Vivian plasma-based assisted technology with microwaves on the right hand to basically make that solar carbon into graphene. This is the commercial technology today. That graphene is 10,000 times valuable than hydrogen. So there are solutions in space that use specialty materials, very high value, commercial carbon to get technologies. That's what's on the next. That's the challenge. How to get the first technology, first kind, and then find the commercial breakthroughs to be able to meet and scale to
That's a great perspective. This started with investments and infrastructure. When we talk about technology investments like for electrolyzers and also compressors, hydrogen turbines, and all the other technologies that have come to come and commercialize and bring us. Okay. So I will also share our perspective a little bit on this. As a company that has been doing this for over 2 years, we've developed and perfected these building blocks, which we feel are very foundational to hydrogen production. On top, we see steam methane reforming and alcohol reforming. Both these use natural gas as a feedstock, but are very different when it comes to CapEx and OpEx implications. Scale, greenfield versus brownfield, and sometimes for some final brownfield projects. So it tends to focus more on those, and then industrial scale production more automobile farming. On top of it, we have what we call the performance improvement blocks. Again, these have been used over and over for projects around the world. And what we need is more optimization. It could be a proprietary equipment we have, or the technology we have, or better utilization, improving efficiencies, steam loss management. So that's sort of the approach we are taking. We think it will take program blocks, but in a fashion. And at the end of the day, we are a company of product and performance capabilities that come with a lot of financial implications. But that's sort of what I think. We really have guaranteed good processes, and that will give developers and investors the confidence to move forward. Try something similar. We might where they have modernized solutions to best integrate the world of electrons and molecules. We know the molecules. We know with hydrogen, ammonia, ethanol, LOFC. Throughout decades, right? So we are trying to manage that experience with the electrolyzer world and bring a value engineered solution. And again, back it up with guarantees, right? That's sort of what I think, it's that guarantee worthy projects that will give investors and developers the comfort level. So with that, I'd like to move our next question. We have a very diverse and not just in terms of the stakeholder and value chain, but we also have experience across the world, right? There's a lot of how different countries are working together. Some are more focused on finance, some are more focused on science, some are more on technology. What's your perspective on that?
For 10 years. It's very important was this completely highlighted in the campus. And secondly, the partnership with this order. Our company announced that our company has completed feasibility study of 60 megawatt alkaline electrolyzer at a system in Malaysia. And in collaboration with I forgot the name of the company and utility company in Malaysia, and also Japanese Nikki, a Japanese EPC company. Then and also the other one, and recently we announced, and Asahi Kasei and Denora signed MOU agreement to jointly develop container type alkaline electrolyzer. Then the container type alkaline electrolyzer allow us to do the POC testing very easily, very small scale, and just hook up electricity and water and just moving. Then such kind of easy the equipment for the POC is very important to proceed a customer the development. And lastly, the innovation point of view, I mentioned before we invested AEF company, and one is the company named Ionomer, they develop AEM membrane. Then our company is working on electrolyzer, but we need to have another option for the future, the technology. Then AEM is one of the candidate for next generation of hydrogen production. And this company overcame drawback of AEM, alkaline electrolyzer, and that is the vulnerable to fluctuation of input energy, and also the PM and PEM, and they use precious metal. Then usually the AEM has issue of durability, but this company developed the polymer technology to overcome the durability issue. And the other company is named the Hydrogen to Power, and based in Ohio. They develop AEM electrolyzer. And currently they have a 10 kilowatt system, but they are scaling up to the 250 kilowatt system. Such kind of a new technology, and our company is working on alkaline electrolyzer, but the CBC point of view, we can bring another option for the future business. Then AEM is a good candidate. Of course, it takes a time and a very early stage company, but we have to keep working on such kind of a new technology and also a new business model in the hydrogen sector.
Nigel, what are your thoughts on this?
Baker Hughes is in 120 plus different countries around the world with 58,000 people. So international collaboration is at the heart of Baker Hughes. We're all working on energy technology and working with our customers and partners, finding solutions, I would say. So, of course, from a large scale standpoint for hydrogen right now, to connect that, it's if it can be done by land, hydrogen stays in a pipeline. If it needs to cross a sea, it's ammonia right now. Mm-hmm. And of course, ammonia plants basically need a certain scale. 1 million tons per annum, really, for an ammonia plant seems to be the phase of development for scaling. And of course, then looking at how the hydrogen and how to achieve, if that's a green-based product, hydrogen, who are the electrolyzer manufacturers that can actually deliver at that scale, massive scale that's needed, because of course it needs a lot of balance sheet to be able to provide that and securitize an investment for the whole project. So there's numerous projects we're working with various technology providers in the reactors, of course on the supply chain, but we work typically at the interfaces. So we're the kind of key interface between the electrolyzer and then the ammonia plant, and then the integration into both of those. So I'll talk a little bit about that later on.
Sounds good. Yohei, do you want to add something?
I will agree on the two, and I'll focus on the international cooperation development in R&D stages. Mm-hmm. For example, when we develop for the hydrogen-fired gas turbine, if it's a middle size, like 40 megawatts or 50 megawatts, we can do it in the test level, not level, but in our factory in Japan, which we show in the Takashi Hydrogen Park. But we also have a facility for large gas turbines. We do demonstration for natural gas fueled upgraded gas turbine, but we cannot do it for the hydrogen fires because we don't have infrastructure for hydrogen. In that sense, in 2022, we collaborate with the Georgian power company to do the demonstration of co-firing on that. If you're going to reach for more higher ratio of the demonstration, definitely we cannot do it in Japan in a few years. So it's very important to have the international cooperation demonstrating where has the infrastructure. It's always coming to like a chicken and egg. Who is the infrastructure coming first, or is the technology coming first? But that kind of things, the project in the R&D point of view, cross-border collaboration is very important.
Awesome. I think that's very much at the heart of our company as well. We are in 34 countries. We have executed all these projects. We are always looking to learn and bring that experience back here in United States. So that's a good segue into kind of the last part of the discussion, which is on end use. And Nigel, I will start with you.
Thanks.
And then we'll do something more interactive with everybody. But my question to you is, hydrogen is touted as the answer no matter who you ask, be it power, be it industry, be it mobility sector. What is your take on it, right? And I'll ask you all specific questions about it later, but if there's one or two applications that you feel you want to put your money on, what is that?
Okay, well, I'll show you where we put our money on. If you could just bring up the slide. Introducing our 100% hydrogen-fired gas turbine.
Not our slides.
It's the...
Okay, it's going on by itself.
Yeah, keep going back. Back one more. So that's just a quick look inside. But this 100% hydrogen-fired gas turbine is the only one commercially available today. It can start on hydrogen. It can go anywhere, but on any range between natural gas and hydrogen on the fly. And so next slide, if you could, Parul, thank you. It actually is back to the future because this started 20 years ago. So this isn't things that actually are available in 2 to 3 years. This goes back 20 years. 2004, the Fusina power plant was devised. It had European money and support. It's on the back of a refinery that you'll see in a bit of the background, taking some of their byproduct hydrogen. And through one of our PGT-10 industrial gas turbines in cogeneration mode, basically firing on 100% hydrogen, operational in 2009, thousands of hours of runtime. That's back to the future. Next slide. Here and now, we have now our Nova range of industrial gas turbines with two sizes, 12 megawatt, 16, 17 megawatt version. That's in simple cycle mode. So in combined cycle, the larger one does 22 megawatts. That's 48% efficiency. So that's a really high efficiency gas turbine working there, running on hydrogen. But in cogeneration, it's even better. So it's up to 80% efficiency in cogen mode. And that's where we're seeing and deploying with Air Products and others. This is going up into Canada, the Canadian project right now, being installed there, will be operational soon. And the picture was taken at our site in Italy, where we do factory testing, acceptance testing of these turbines before they go out. Just next slide. We were showing a video earlier on. We've got hydrogen storage on site, hydrogen network, control room to operate the turbines, be able to go in between natural gas fire and 100% hydrogen on the fly during operation with no stability issues. Next slide, Paul. And so there was also some discussion about modularization. So this site basically does mega scale modules as well as smaller scale modules where we integrate compression into things like electrolysis, but also large cogen systems for our customers. You'll probably just see on the right at the back there at the port, one mega module being loaded, which was a cogen facility for the big Gorgon LNG plant down in Australia. And this is where we do all of the manufacturing. You'll see a few of the big modules still under fabrication in the yard there as well. So to answer your question, end use, cogeneration just makes so much sense if you've got hydrogen on site or any mix of hydrogen. It's efficient. the high heat content of hydrogen, coupling that with steam and steam use as well as the electrons makes a lot of sense for our industrial customers.
Sounds good. So looks like, the power seems to be one of the favorites and industry as well. But let's, before we hand over to audience questions, I'd quickly ask you guys about different industries or sectors where hydrogen is a potential use case. If you think that projects will take off this decade, not by 2050, this decade, right? Yes. If you don't think it's happening this decade, and if it may not, right? Okay. So, and that will lead to the audience question. I'll let the audience, ask you to explain that. Feedstock for chemicals, fertilizers, refinery, plastics. I will maintain a neutral position. You guys go ahead.
Yeah, I don't think it's.
I would say refineries, yeah.
Yeah.
Okay. Products, steel, glass, use of hydrogen.
No.
Steel, DRI,
Okay.
makes complete sense.
Okay. Then let's move to heat, right? Industrial heat for steel, cement, paper, food, aluminum.
Double thumbs up from me for that.
Okay.
Strong.
Okay. Building heat, right? We hear about, homes being heated, powered by hydrogen in some parts of the world. Residential, commercial, building heat. Yes, no, maybe. This decade. Okay. Let's also talk about fuel. Mobility, by road, by sea, by air, hydrogen. Announcements are everywhere. What hits? What happens this year?
Ammonia turbines for shipping.
Yeah.
So yes for what? All three?
Ammonia turbines for shipping.
Shipping.
That makes sense.
What about road? Transportation, trucking?
Yeah, heavy duty.
In some market, yeah.
In certain areas.
Okay. And air, e-fuels,
For the future.
sustainable aviation fuel.
Oh, e-fuels we count.
E-fuels, right? Through hydrogen. This decade?
This
projects?
decade.
Yeah? Okay. And then power, electricity, peaking, seasonal balancing. I know your answer for this.
Yeah,
But
it's of course yes.
okay. So with that, thank you for your candid answers, right? And I'll move to audience questions.
So my question's kind of for you, Nigel. So I've heard so many people say there are no turbines that burn hydrogen, and you have one. So what do you say to that? And I'm curious what Mitsubishi has to say about hydrogen turbines too, because I visited Takasago, and I know you guys are pretty far ahead on that as well. But what do you say to all the naysayers, Nigel? You clearly have one.
So yes, we have one for industrial use cases, that's scale. So scale matters, right? So if somebody says, is a gas turbine available for large-scale power generation, 300 megawatts, at the moment, no. But 100% hydrogen, but co-firing, yes. So it matters with the actual design of the type of turbine. We were able to modify our industrial turbines to run on 100% hydrogen. So, but that's more of a challenge for the much larger scale gas turbines that are conventionally power generation, like standalone power generation for utility grid requirements. So that's still a few years away, and of course people are looking at ammonia firing for those as well. There's our brethren at GE working with IHI in Japan, talking about collaboration on ammonia firing, and we're looking at as well moving our industrial turbines over to ammonia as well, and also having a dry low NOx version for hydrogen. So there's a lot of development still going on, but you're right, Brian, it's available basically 20 years ago that Fusina project was designed. 20 years ago.
Mitsubishi view?
Yeah, I think I agree with you for for comparing like middle size or large size gas turbines, ammonia, that will be definitely starting from the middle size. Large size, the combustion temperature is a little bit high. That means high NOx issue will be the issue. Of course, we're going to try continue to resolve that issue. And also for the demand side, the industrial is a very some industrial companies have a strong commitment to that. So like cogeneration, CHP, those kinds of solution with the hydrogen will be a very, I think it's a very good market for starting. Yeah.
So for a 300 megawatt, you think 3 to 5 years it'll be productized, or?
I've heard the early 2030s basically productized even for an ammonia fire turbine. So the early 2030s at that scale, 300 to 500, the big H-class. Yeah.
Other questions?
Great. Thank you so much. A large part of the conversation is focused on centralized hydrogen production. First question is like, what are your thoughts on distributed hydrogen production? Because that will alleviate the need for pipelines and an infrastructure grid. The second aspect of the question relates to a little bit more, what are the key beachhead markets for hydrogens, right? For example, are submarines a good beachhead market? Are unmanned drones a wonderful beachhead market for hydrogen aviation? Is there a different way of thinking about this? And I'd just like the expert panel view on these kind of things.
You want to start?
I mean, being open to lots of different use cases. Like, you know, as a technologist, you've got to let, you know, the freedom of ingenuity shine and the market adopt where it wants to versus other options. And so yeah, we're completely open to, of course, the scale and the supply chain for hydrogen then is a challenge because you're talking about very different volume cases and demands and how that's produced and then delivered to the use case, the end consumer. So I guess having the variety out there makes it confusing because there's so many different options. Choosing which one to bet on, if you like, you know, is what CVCs do and of course technologists, I'm sure, are finding ingenious ways to develop new solutions. So long may it go forward.
Yeah.
I'd also add to your point of distributed versus, you know, centralized, right? I think a lot depends on what's available. If you have large-scale natural gas available, right? ATR technology, which uses a lot of oxygen, which uses a lot of electricity, right? Those have to be large-scale. You know, back to Nigel's point, it's putting the right technology with the right resources, feedstock, you know, with the right application. So it's going to be a lot of things, and to your point, absolutely, distributed is very much part of the answer.
And of course, you know, regulations are required, right? So, and this is where Texas is taking the lead, I would say even internationally with the state work to look at regulations for hydrogen. And of course, another plug basically for the Railroad Commission's Hydrogen Production Policy Council, which I'm a proud member of and producing a report, you heard it earlier on today. So that will help, of course, set standards that most technologies can fit to, but of course there's a plethora out there that you have to think about, have safety in mind for, and yeah, look out for that in the future.
Yeah, I have one thing I want to comment. And I think a new application is There are a lot of the new application and like a green steel, but I think one option is the data center. And recently, the AI spread in increasing the data center. Then data center consume a huge amount of electricity. Then the one option to build power generation using hydrogen. Then the most of the large IT company are operating the data center. They are very aiming for become environmental friendlier company. Then I think the key point of a hydrogen one challenge of hydrogen is to higher cost. Then, but the IT company are willing to pay extra premium on the higher cost. I think finding a customer willing to pay higher cost is very important in the hydrogen and the sector. That is the key point to identify the hydrogen application for future.
Very exciting area.
Yeah.
All right, thank you so much.